Okay. You guys, so far, we have graphed this function right here, f of x equals x squared. We learned how to reflect it, didn't we? Left and right, and we learned how to move it up and down. If I want to move this left 3 and up 1, what do I do? Okay, wait. I want everybody to think about that for a second. Some of you guys aren't even thinking about this. Look up here. Pay attention. Come on, you guys actually have to look up here and pay attention. What would I do? What would my new equation be if I wanted to move this function, x squared, left 3 and up 1? You know it. Raise your hand. Think about it. Some of you guys haven't even looked at the problem yet. F of x equals x squared. If we want to move it left 3 and up 1, what would we do? Okay? All right, Kyle, what do you think? Uh-huh. In parentheses, right? Okay, why? Is that correct, by the way? Yeah. Why is it that I do the x plus 3, you guys? Yeah. Because, say that again? Because x plus 3, it goes the opposite way. This is what moves it left and right, the x plus 3. And to move it up 1, I add 1, right? So what it does, if I move this left 3 and up 1, this is what it's going to look like, right? Because the original one is right there at 0, 0, its vertex, and I moved it left 3, and up 1. Got it? That's how you move it left 3 and up 1. What if I wanted to flip it upside down? I could put a negative right here in front of the parentheses, and now it would go like this, right? Okay, do we understand that? Does everybody understand that? Okay, now, this is what we're going to do in groups. I only taught you guys how to do this with x squared. I want you guys to learn how to do this with other types of functions. So number 1 is going to be f of x. Everybody write this down on a piece of paper. We're going to do this as a group activity. F of x equals x cubed. Number 2, f of x equals the absolute value of x. Number 3, f of x equals the square root of x. Number 4, f of x equals 1 over x. Am I forgetting one? Number 5, f of x equals x. Okay, now, I want you guys, we're going to name each type of function right here. This first one, what kind of function is this one, you guys? Happy birthday, Max. That's what happens on your birthday. Max thinks he doesn't have to come to class. No. That's all right. Okay. All right. Everybody, we're going to sing Happy Birthday, Max. Hey, you guys, do we need to shut the door, or can you guys sing better than last time?
Hey, I'm the head singer now, so
Wait. I need someone that knows how to sing. Give us a note on Happy Birthday.
We can meditate all
Okay.
day.
Wait, we need you to do it. You're a good singer. I've heard you.
Yeah.
Yes, I have. You sing all the time in this class. Okay, 1, 2, ready, sing. Happy birthday to you. Happy birthday to you.
Cha cha cha. Amen.
I should have. Who we missing that needs to sing this? Jessica? It just sounded better to you because it was your birthday that day. Because that was the best we've done in this class so far. We're getting better. All right.
Oh, we sing best for yours.
I don't think you guys sounded very good that day. All right. Okay, you guys. What type of function is this one called? Cubic. Good. What kind of function is this one called? Absolute value. This one's called, good, square root. This one is called a reciprocal or rational. Think about the word ratio. Ratio means a fraction, right? So rational is a fraction. And this one right here is linear. Good. You guys are recognizing now. Okay. Oh, I forgot one. There's one we forgot. Y equals 2 to the x. What kind is this one? Exponential. Exponential. Those are the 6 kind we're going to learn how to move around today. Now, can you see that? Because I need to... Who? I have no idea what his schedule is, but I can look it up. Why? Okay, here we go, you guys. We are going to... what I want you guys to do is I want you to shift each function left 3. Up 1 and upside down. Hi, Lindsay. That's from who? Alexandra Smith. You are always getting called out of class. What is the deal? Okay. Hey, you guys, this is what we're doing. Okay, listen. In your groups, that means U4, 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 and U4, and U2. Actually, do you guys want to combine with a group? Or do you guys want to work on your own? Let's do this. You two work together, and those 4 will work together back there, okay? You and Chelsea, okay? Okay, you guys, I want you, listen to the instructions. Cal, listen to the instructions. I want you to figure out how you would take each one of these functions, like the x cubed, shift it left, F3, up 1, and upside down. So it's all 3 of them together. So you get the end result is shift left 3, up 1, and upside down. Okay? Do it with all 6 of these functions. I'm going to give you about 10 minutes to work on it, and then we're going to go. So first of all, x cubed. You hit the x button, you hit this button. What is that button? It's the exponent button. Whatever comes after it is the exponent. So that's x cubed. If I graph that on a standard window, that's what an x cubed looks like. So if you guys notice, an x cubed has a focal point right there. You're going to move that focal point left 3 and up 1, so it's going to be there. Got it? Okay, next one. An absolute value. How do you put an absolute value function in your calculator? Okay, you go to math, over to number 1, and you put in x, and you hit graph. And that is how you put an absolute value function in your calculator. Math, go over to number, which is for the right one. And the first one says absolute value. Okay? Next one. Square root of x. You hit second and the x squared button because above it has a square root. You put in x, you put in the ending parenthesis, and you graph it. This one right here starts at 0, 0. You're going to put the starting point at -3, 1 instead of, and it's going to be upside down as well. So it's going to be the other, it's going to be reflected down over the x axis. Okay, the next one. How do you put in 1 over x? You just go 1 divided by x. And you graph it like that. And there's two parts to this function. This function has a focal point right between those two parts, a 0, 0. You're going to move that focal point left 3 and up 1. So it's going to be right here. Got it? Left 3 and up 1. This function, you guys, looks like this. It goes forever down and to the left, but it will never cross the x or y axis there. Same with that one. Okay? You got, how do you add to the left? Let me tell you. Okay? You guys, to shift something left and right, you have to put parentheses around it. You have to put it inside a function. You don't always have to use parentheses depending on what function it is. But you have to put it inside the function. So you have to replace x with x plus 3. Got it? Read. Oh, cool. Okay, now, next one. The x. You guys all know how to do that one. Y equals x. That one should be pretty simple. And it looks like that. Got it? It's a linear equation. And the last one. 2 to the x. You push 2, you put the exponent button, which is that caret key right there, and you push x, and that means 2 to the x power. And you graph that. And there's the exponential function. You guys, on the exponential function, let me just give you a hint. At 0, 1, you're going to move that point 0, 1 around, because 0, 1 is on the graph. And you're going to move it left 3 and up 1. So if you move it left 3 and up 1, it's going to be at -3, 2. Got it? Okay, now that we know how to put each of those functions in the calculator, see if you can do that. Okay, you guys, we're going to do this now. Everybody look up here. You guys, this is going to help you with your homework. If you don't know how to do your homework after this, it's because you don't know how to do this. So watch. Everybody turn around now. You're not in groups anymore. Turn around this way. Okay, right here. I am going to take the x cubed function, first of all, and I want to turn it upside down, so I put a negative in. Okay? And then to move it to the left 3, I've got to replace x with x plus 3. That means it's got to go in parentheses. So parentheses x plus 3. And I have to cube that whole quantity. So I hit the caret key and 3, and that cubes the whole quantity, x plus 3. And then to move it up 1, I just add 1 to the function, and there it is. If I graph it, it looks like this. That's what your x cubed function should look like after you do those shifts. Do we understand that? I think most of you got it, but some of you guys are still lost. Okay, here we go. Next one. Let's clear that one out. Okay, the second one is the absolute value function. First of all, I need a negative because I got to turn it upside down. Then I got to do absolute value. So I go to math. Go over to number, and there's the absolute value. And then I put in, to shift it left 3, what do I do, everybody? X plus 3. I want everybody doing this at the same time as me. So everybody get out your calculator and do it at the same time as me. Whether you've done it or not already. I want everybody. Anthony, you need a calculator.
I have a calculator.
Then get it out and start doing this. And then to move it up 1, you add 1. So negative absolute value of x plus 3, add 1. Moves it up 3. So that's how we put that one in. This is what it looks like. It's upside down. The vertex is at negative 3 comma 1. If yours is different, Lacey, look to see. I got a negative absolute value, in parentheses x plus 3, to move it to the left 3, and then add 1 to move it up 1. Okay? If yours is not upside down, it's because you didn't put a negative in front of it. That's how you make it upside down. Okay, the next one. The next one is the square root function. Well, once again, I got to turn it upside down, so I got to put a negative in. I got to go to the square root. I got to do x plus 3 to move it to the left 3 units. And then I got to add 1 to move it up 1. So you only square root the x plus 3. It's an inside thing. Don't do that. Whoever's whistling, don't do that. I don't know who it was. Okay? Square root of x plus 3 plus 1. Now, you guys, right here, just remember, inside the function shifts it left and right. Outside the function shifts it up and down. So the x plus 3 is inside the function. You're taking the whole square root of that. Okay, and if we graph it, that's what it looks like. That's what your graph should look like. Okay, next. The rational function. This is the one that seemed to give you most of you guys a hard time. First of all, I need it negative. So I put in negative 1 divided by, and you're replacing x with x plus 3. So that means the parentheses go right here. X plus 3. So negative 1 divided by the x plus 3. The x plus 3 shifts it to the left 3. And add 1 to move it up. Raiden. Did you get this graph right here? Then you got the wrong graph. Yeah. Negative 1 divided by, in parentheses, x plus 3, because you replace x with x plus 3. So anytime you guys replace x with x plus 3, you got to put it in parentheses. And then you add 1 to move it up. Any questions there? And that's what the graph looks like right there. That focal point moved left 3 and up 1. And you got that. Okay, any questions there? Okay. Linear, you guys, I'm going to tell you right now, we could graph this one by using the same things we just learned. You can go negative, and in parentheses, x plus 3, to move it to the negative moves, flips it upside down, so it has a negative slope instead of positive slope. The x plus 3 moves it to the left 3, and the plus 1 would move it up. But do you guys remember slope-intercept form? I want to show you this. Slope-intercept form looks like this. Y equals mx plus b, right? Sometimes it's easier to put it in like that. If I took that function I just put in, y equals negative x plus 3 plus 1, like that, and I distribute the negative through, so I get y equals negative x minus 3 plus 1, and I add like terms, y equals negative x minus 2. That y equals negative x minus 2 is going to be the same thing as what I put into my calculator. I want to show you that slope-intercept form. And usually, if you guys ever see a graph like this, it's easier to do it in slope-intercept form. But if you're given something like I gave you right here, it's easier to do the way doing the shifts the way I taught you. Yes? No, not on a linear. A linear is a line. It's x to the first power. Just on the parabolas, we use the squared. Okay, and I'll show you one like that in just a second. Okay, I want to show you one. Okay, now the last one, you guys, 2 to the x power. First of all, this is another one you guys missed a lot when I was going around helping you. Negative 2 to the x power. But instead of x, what am I going to have, you guys? Instead of x, what am I going to have? No, x plus 3 in parentheses. I'm replacing x with x plus 3. We got this? I'm replacing x with x plus 3. And then I add 1 to the function, and it's going to move it up 1. Negative 2 to the x plus 3 power plus 1. And that's what it should look like. Okay, it takes your exponential function, flips it upside down, and that's what it does. Okay, any questions there? Man, here we go. Next one. That's it. Now, you guys, I can take any function. D, I want to talk about yours first. Let's say I want to do x squared. D, this is what you're thinking of. Y equals x squared. If I had that function, then I'm going to put a square in. If I want to flip it upside down, I put a negative. If I want to move it to the left 3 units, I put parentheses x plus 3. That moves it 3 units left with the squared. And then I add 1 to move it up. Okay, and that gives me a parabola like that. That's when you use a squared, only when you're graphing a parabola. Got it? All right. Any other questions?